Okay, previously when we think about trigonometry, we've been thinking about right triangles, right? Of course, it has to be a right triangle, but what if it's not a right triangle? What if it's an oblique triangle, okay? They have no right angles. We're going to use standard notation. Just a little note here. Angle A opens up on side A. Angle B opens up on side B, and so on, that kind of thing. Hopefully that you remember that. If we want to solve an oblique triangle, you need to know the measure of at least one side and the measures of any two other parts of the triangle. So you remember angle, angle, side, angle, side, side, angle, side, 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 and side, angle, side. You remember these things. So the first two cases can be solved using the law of sines, and that's what we're going to do down here. If we have two angles or if we have two sides, okay? And so let's go down here and see what it looks like. In this triangle here, if I know, let's just focus on the first part. If I know A and the sine of A and the sine of B, in other words, if I know two angles and a side, I can find the other one, okay? And I don't have to even care about C if that's, unless they give me C, and then I care about it. You know, I need to know 3 out of 4, and then I can find the fourth one. And if you'd rather, you can write the sine A on top of A. So you can write them in reciprocal form if you like. It doesn't matter. They're still equal. So A over the sine of A equals B over the sine of B equals C over the sine of C. And if you want to leave out A or B or C, you can, but you're going to need 2 of those at least. Well, you need 2. Okay, so we look down here and we see this triangle and we say, they've given me an angle and another. That's 2 angles and a side. So I think they were smart to use the sides on the top, okay? And we're going to care a lot about B, and we're going to care a lot about C. And you know, for this problem, we don't care about this part, so we leave it out, okay? It's not that it's not there, we just don't care right now. And so I guess they found it anyway. Yeah, I guess they found it anyway, but it's fine. You could find it, it's no problem. Did they ask us to find everything? Find the remaining angle. Oh, okay, so we had to I guess we do care. We had to find everything. But if we were just after C, we wouldn't care about A. But since we have 3 angles in a triangle, we know we can find the third one. We subtract from 180 and so forth. Okay, not that they do it that way here, I guess. Yes, they do. Yes, they do. They subtract from 180. There we go. Okay, so let's go ahead. We're going to solve, apparently we're going to do the whole triangle, okay? I was going to just do part of it, but we'll do the whole thing. So, we know this angle, we know this angle, we know this side. So I'm going to put my sides on the top. I could put my angles on the top, but since I don't know the side, I'm going to put the side on the top. And I'm going to say 12 inches over the sine of 25. Might want to switch your calculators to degree mode again. If they were in radian, it's time to switch. We also know that B, which I don't know, is over the sine of 60. And then I'm going to say, you know, eventually I'll figure out C is over the sine of C. And it looks to me, well, it looks like a 90-degree angle, but it's not. It's not. You can see we have 180 minus 60 minus 25. If I wanted it to be 90, that'd have to be 30, but it's not. So I'd say it's going to be 95. So it may look like a right angle, but it's not. So I guess we can say 95, and we probably should say 95 down here. Okay. So we can do this a variety of ways, but I think I will just do it like this. I will say B times the sine of 25 is equal to, and then we'll go this way, 12 times the sine of 60 And I know most of this. And also, let's see, I'll just go ahead and divide this side by the sine of 25 while I'm at it. The sine of 25. Okay, so I get my calculator out, and I say 12, and I say the sine of 60, which I kind of know already, but anyway. I multiply those together, and I take the sine of 25, which I don't know so much. Glad for my calculator. And I divide, and that gives me b is equal to 24.59. So b is equal to 24.59. And I look up here and I say, does that make sense? Well, this is a little side over here. It's 12. B is a long side. So sure, that makes good sense. It's a lot bigger than 24. Oops, didn't mean to do all that. It's a lot bigger than 20. It's a lot bigger than 24. So anyway, don't want to put too much on here. So there's B. And what's left for me to find? Well, I'd still like to know C. So now that I know B, I can write 24.59. Do I really need to use B? No, I could go over here and use A. Maybe that'd be easier, but I know B now, so I want to use it. So let's use it. B over the sine of 60 is equal to C over the sine of 95. Okay, and I'll do the same thing. I'll say 24.59 times the sine of 95 is equal to C times the sine of 60. Cross multiply. I'll divide both sides by, I will try to divide both sides by the sine of 60. And I will find C when I do this over here on the left. So I say 25. I still in my calculator. How handy. The sine of 95. That's almost 1. That's so close to 1. So I multiply and I get basically the same thing. And then I say sine of 60 and I divide. And I get 28.29. And that had better be bigger than B because C is the hypotenuse. So there's B and C, and I guess I should write down here the big angle C is 95 degrees. Okay, those are the three things they didn't tell me, but I can find them with the law of sines, and it's a great tool. And we almost had a right angle anyway, but that's not a right angle. So we didn't need a right angle because we have the law of sines. It's pretty handy.